And it's equal to 0, right? So I'm going to set each one of these equal to 0. And solve them. So this one's already solved. That's easy. This is x equals 3. And then this one was x equals -6, right? Couple observations. Just want to point them out to you at this point. Notice the third power here. That indicates there's 3 solutions. 1, 2, 3. Okay? These are 3 real solutions. Sometimes you're going to end up with imaginary solutions, but today it's real. Okay? But this tells you how many you should be getting. Sometimes those solutions get repeated. Like you'll have 2 zeros. And that just means it's a double root. Could get tripled, but usually it's single, double, and rare occasions triple. The other thing I want you to notice is what's the relationship here between x minus 3 and that positive 3? What pattern do you see here? It's right here also. The signs are opposites, aren't they? That's going to be helpful when it comes to writing equations. If you recognize that this part right here is called the factor. This is the solution that came from the factor when you moved it over. Does that make sense? So just get used to those terms. This is the factor form. This is the solution form. All right? Now, let's do number 2. Look at those 2 terms. What can I take out of both of those?
X squared.
Okay. And then I'll have x squared minus 4. Can I keep going?
Yes.
What is that?
It would be x plus 2 and x minus 2.
What's that called? You're right. Difference of squares. Yeah, you're right. Difference of squares. Yep, she just went further. So it's an x plus 2, x minus 2. That x squared came along for the ride. So if I set each one equal to 0, all right, well, x squared equals 0. That just means that x is 0. This one in factor form, that's going to be a -2. And this one will solve to be +2, right? So notice this, though. Look, our exponent was 4. That means I need to account for 4 solutions, but I only have 3.
Well, it has a multiplicity of 2, 0.
How do you know it has a multiplicity of 2? Because it is squared right here, that means I could have written it again over here. And that means I'd have 2 zeros. So we call this a double root. You don't have to do this part, but because this power is 2, this is a double root, so it counts as 2 solutions. 3 and 4. There's my 4 solutions for that equation. Is that all right? Why does that matter? Because when we go to graph these guys in the next session, okay, so we know it's hitting the x-axis at 0, and we know it's hitting at -2, and we know it's hitting at +2. And we already determined the end behavior, right? That means the far edges, they're both going up, so I can do this. So the next thing I have to do is figure out what's going on in between those values. Is the line going through the x-axis, or is it bouncing off, or what the heck is actually happening? Well, being a double root, that means it's going to bounce. So it bounces at 0, so that means it's going to go through the single roots. It goes through, just like normal. So it's going to go through the -2, but when it goes to 0, it's going to bounce off of it and go back down the same direction. And then it should make sense that it will go through the +2 because we know it ends up having to go up, rising. Okay? It's kind of a little puzzle. All right? So let's jump over to this one. So I want to come back and do like an example 3 with you before we end for the day. But these first ones. So in 3.2b, I was having you sketch the graph. Using all the stuff we just did, sketch the graph. And I did that on the last example, but it was just extra. Okay, so the first thing we need to do is apply the leading coefficient test. I need to decide are the ends going opposite directions or are they going in the same direction? In which way? So look at my equation. It's x to the third and it's positive. So what does that mean? So it's odd and positive, right?
Oh wait, no, it's right rises, left falls.
Yes. It's like a positive sloped line. Okay, the ends are going to go like that. All right. Find the zeros. That's what we just did. That just code for solve for x. So if I look at my three values, what can I take out of all three of those? An x. So let's do that. So we have x squared minus 2x minus 48. Will this factor?
Yeah.
What two numbers will multiply to negative 48 but add to negative 2?
6 and negative 8.
6 and negative 8, yep. So x plus 6, x minus 8. Then I set each one equal to 0. Solve it. All right. Now, if I look back, how many solutions should I have?
3.
3 solutions. Do I have 3 solutions? 1, 2, 3. That means these are all singles. And this is what we call the multiplicity. They're singles. Okay? That means they're just going to go through the x-axis like normal. No biggie. All right. So if we draw the graph, you don't have to do this piece right here. I'm not going to be OCD about that. But I am going to be looking for your x values. So we know it's going to hit at 0. We know it's going to hit at negative 6, so plot it and label it. And we know it's going to hit over at 8. And based on the multiplicities being singles, they're just going to go through. But we got to decide which direction, right? And the way we know our direction is from this guy. We indicated our end behavior is going to go opposite directions like in a positive slope. So that means over here it's going to go down. Over here it's going to go up. We got to figure out what's happening in between. But since everything's just a single multiplicity, it's just going to flow through like a roller coaster. No big deal. And connect the dots. Is that okay? I'm not going to give you anything super wonky, but you got to be able to show me you can do that much. All right? Now the other type of question you're going to see, and I'm going to give you a lot of time to work, is what I did in the notes, but like on example 3. Okay? That's weird, right? We're finding the equation given the zeros, the multiplicities, and the degree. What the heck? Okay? That means what? These are the zeros that we found right here. This is the multiplicity. And this is the degree right here. Okay? So it's like I'm giving you pieces of the puzzle and you've got to work it backwards a little bit. And notice, or remember what you told me about these. The zeros are opposite signs from their factors, right? So the first thing you have to do is take the zeros that I give you and put them in factor form. So like negative 6 in factor form looks like x plus 6. 8 in factor form is x minus 8. You see the pattern here? So if I go back to my example 3, let's go back here. I have a 0 of 2, or negative 2. So that means what would my factor look like? It would be x plus 2, because when I solve it, it would become negative 2, right? And I have a 0 of negative 1, so that would be x plus 1. But that's only 2 solutions, right? When I tell you the degree, this is how many solutions it should have. So that means that one of them has a multiplicity of 2. Which one? The negative 2 does. So the way you write that is you put a little squared on that factor. Okie dokie. Now, there's a couple ways you can leave your answers. If you leave it like this, if the directions say leave in factored form, that's what it looks like. All right? If I say multiply it out, or I don't indicate factored form, that means you're going to multiply them out. So that would mean I would need to take x plus 2 times x plus 2 times x plus 1 and multiply it all out. And you're like, how the heck do you do that? Well, baby steps. Let's just FOIL it, all right? We're going to FOIL the first two. So I have x squared plus 2x gives me 4x plus 4 times x plus 1. Couple ways you can do that. You can distribute, or I make a box for myself because it's just a little easier for me to see it. I'll put the x plus 1 down the side and the 3 terms across the top. And then it's going to kind of treat it like a Punnett square where I bring them together. So x times x squared will give me x to the third. 4x times x gives me 4x squared. 4x is 4x. This will be x squared. This is 4x, and this is 4. All right? If I've done it correctly, the diagonals will be like terms. And I can combine them. So I have x to the third, and then I combine these two, right? That becomes plus 5x squared plus 8x plus 4. So if I ask you to multiply it out, this is what I would ask you to do. And I wouldn't give you something that's going to take 12 days to do it. I promise. I just want you to know the terminology. If I say factored form, you can leave it like that. If it says multiplied out, then it needs to look something like that. Are we good? That's a lot. It's a lot on a pseudo Friday. Okay? Maybe you remember this from last year. I don't know. 2 years ago, hopefully.